What that means is you are a candle, and you are burning with your little flame, and you can light somebody else by telling them what you know. And you're not losing anything, you're going to still burn. So the second talk that's going on is a little bit of that. It's somebody that is sharing kind of like a personal thing about what they've done. And that sort of thing you will see is it doesn't have to be long, it can be kind of short, but it definitely does help expose other people to kind of cool stuff. Some upcoming events that we have is we have the JavaScript, the what you need to know parts, which is a little play on the good parts and bad parts. And that's actually a workshop, and that's a cross-pollination event with HTML5 group, I believe. And then in April, we've got James Shore coming in from Portland to give a great little talk. And then on May 20th, we've got JavaScript Modern Tooling. And likely, between now and then, there are going to be some other events added, so definitely do keep an eye on the meetup group. So before we jump into the awesomeness, I'll let Tony say a couple words. Tony? Sure.
Hey everybody, I'm Tony UV, Tony UC. I want to thank Randall and Toby for graciously allowing this collaboration effort to take place between the two groups. I took part in a JavaScript meeting a couple months ago, and it was great. I was really surprised about the number of attendees, actually pretty jealous. I run the OWASP Atlanta chapter. OWASP, for those of you that do not know who we are or what we do, we are an international nonprofit organization focused on securing web application. And we cover multiple different sides of the web app stack, client side and server side related technologies for web application, web services. And so we've been reaching out to a couple different technology groups in Atlanta, seeing where we can have a kind of a cross-pollination effort. So if you haven't heard about OWASP, there's a lot of different tools that you might be interested in. And I just wanted to introduce the OWASP.org page. So literally there is a tools or projects. There's a download section here, OWASP initiatives. A lot of the major projects that OWASP has is basically in denoting what sort of vulnerable things exist with web applications from a client side, from a web services standpoint, from architectural standpoint. So there's a lot of great information on here. There's content for builders, breakers, which basically means people that are trying to defend against hackers, people that are trying to actually emulate hackers. And so there's a lot of different types of good stuff. There's a lot of different types of projects that we hopefully that you might gain your interest as JavaScript programmers. We meet every month here in Atlanta in the Dell SecureWorks building in the perimeter area. It's nice, it's not this nice. This is pretty impressive and this view is amazing. But nonetheless, we get together every month. So if you're interested to learn more about our chapter, actually you would go to, you do a keyword search up top right for Atlanta, and you would find our respective Atlanta page. And there you can also go to meetup.com/OWASP-Atlanta, and you can get some more information there. And again, all that we focus on is security, so how to prevent hacking, or how to actually do some hacking testing for your own web applications that you might be working on. So with that, I'll be quiet and pass the mic back to Randall.
Cool. Well, thank you. And also, like, the website's really cool. So if you're ever doing a project and want to know something about maybe like a best practice, or you're looking for some sort of documentation that you can refer to, that's definitely loaded with that. So I'm going to shut up myself and just pass it along to our first presenter. So yeah, that's it.
Hello everybody, very nice to be here in front of such a big audience. This is probably one of my biggest audiences yet. My name is Nadisha, and I work for HP Security Research as a principal researcher. My day-to-day job includes looking at web application tech. I figured I could get by without doing that.
You tried.
Yeah, I think so.
Test.
So my day-to-day job includes looking at web application technologies and evaluating them for vulnerabilities, and then devising algorithms to detect those vulnerabilities automatically. So for past 1 year or so, I've been looking at HTML5 and technologies that are coming out of that, and it has been amazing. Amazing in terms of the security, because you can find a lot of good stuff that you want to share, and that's exactly what I'm here for. Giving you a little bit overview of what HTML5 is in terms of security when we're talking security and HTML5 in the same context. And also answer the question, are there any vulnerabilities in HTML5? And one of the main goals that I have for my presentation is actually debunking the myth that if I'm not using HTML5, I do not have to worry about HTML5 security, because you will find out on the course of this presentation that even though you are not using HTML5, you are actually getting affected by HTML5. So let's look at this slide, which one tells us what HTML5 is. And what I want to tell you is what HTML5 is not. HTML5 is not something that we normally associate HTML with. Markup. What it is, it's actually a combination of various different technologies like browser enhancements or client-side technologies. All of those improvements, they're all bundled under this one name, HTML5. And when you have so many different moving pieces, there's a high propensity that something will go wrong. And unfortunately, that's not an exception here either. Now, I can't really go over all of these technologies and tell you about the vulnerabilities in all of them for this presentation. So what I have done is pick 3 technologies from that we think that would be most used and early adopted by the developers across the board. And they are most intriguing in terms of the kind of new vulnerabilities that they are introducing into the system, as well as sort of regression that they are bringing in terms of, we all probably know a little bit about security and kind of vulnerabilities that are out there. And what HTML5 technologies are doing is sort of bringing in mechanism to overcome those protections that you have built into your application to protect against these vulnerabilities, such as cross-site scripting, very primitive sensitive data disclosure, and cross-site request closure. So I figured that quite a few of you are from development background and not from security background, so you might not actually know that what these vulnerabilities are. So first in the stack is cross-site scripting. Very simple vulnerability, very widespread, and very easy to exploit. What you have is a URL and a URL with parameter. What happens is, when the server returns a response, the value of the parameter gets included in the response and becomes rendered content on the browser. Attacker notices this behavior and tries, okay, what if I try a script block instead of just the benign parameter value? Sure enough, when the response comes back, browser renders it and it ends up executing that JavaScript. Very simple. But if you think about it, if you can get a JavaScript execution in context of a page, you have access to everything that's there on that page and that side that the JavaScript can possibly do. Second, sensitive data disclosure. Everything that we send to the client is available and visible on the client side. It doesn't matter if it did not get rendered on the page. So anything that you included in your HTML or you store in the cookies, they can be viewed. And oftentimes, as security professionals, we get a little chuckle out of when encoding is considered encryption. Like base64 is not an encryption technology, it's an encoding. The third in the stack is cross-site request forgery that I'll be talking and using a lot in this presentation. It's little bit harder to understand, little bit harder to find as well, but when you exploit it, the price can be very precious. So, in order to understand this vulnerability, we're going to take a help of our friend Alice. What Alice wants to do is, she wants to go online and check her bank account. So she tells browser, hey, I want to check my bank account. Browser contacts bank server, hey, Alice wants to check her bank account. Browser says, bank says, okay, yeah, she needs to identify herself. And Alice does so by giving her username and password credentials to the browser. Browser hands them over to bank, and bank verifies the identity and gives an identifier token to browser. This token bank expects to be included in every single request that Alice makes now onwards. So browser goes ahead and gives that token and makes a note that, okay, I have to send this token every single request now onwards that are made to this bank. And while this is all happening, Evil Bob comes in. Yeah, there's a good story going on here. What Evil Bob wants to do is give Alice a free iPad. So Alice is like, yeah, free iPad, why not? Everybody likes free iPad. I want to have a free iPad. She tells browser, hey browser, I want to get my free iPad. Load this freeipad.com for me. Browser loads it. What Alice does not know that freeipad.com has a link to bank.com. And not just a link, but link with an action to transfer money from whatever account to Evil Bob's account. Now that whatever account gets identified as Alice's account with her identifier token that bank had handed over to browser. And browser had made a note that every single request that I'm going to make to bank is going to be made with this identifying token. And this all happens without knowledge of Alice, because Alice did not know that there is a link to bank.com in that freeipad.com. Browser did not know that Alice did not make this request, and bank sure did not know that the request that just came in is not initiated by Alice's action. So, what ends up happening? All the money from Alice's account is gone. So it's a simple vulnerability, hard to exploit, but when you find the exploitable instance of this vulnerability, the consequences are serious. So what do security professionals do? They go to Black. They find out how to protect against this. The very first protection mechanism, let's check the referral header. Every request that comes to bank will say, is it initiated by bank? I'm going to check it by the referral header. But as you all know, referral headers can be very easily bypassed, or browser may choose not to send them. Not very reliable solution. Okay, we're going to find another solution because this is a serious problem after all. So we came up with something called anti-CSRF tokens. What anti-CSRF tokens are, they are the unique tokens that get included in every form. So think about this. If you want to transfer money to somebody's account, you first have to request this form where you will enter the amount that you want to transfer and probably the bank account number that you want to transfer to. So there's a form and then you will hit submit. So bank knows. When this if I have this identifier, if the request is coming for the transfer, somebody has to have requested this form. And when the form gets submitted, this value goes to the bank. It's a unique token. It cannot be repeated. Every time you request that page, it's a new token gets generated. So there is no way that you can make a request, a legitimate request to the server with that token and the identifying token of Alice. So, pretty good solution. It was attacker's time to go back to Blackboard, and they do figure out how to bypass that. All they want to do is bypass anti-CSRF token, and the way to do that would be to trick the victim, or Alice in this case, into interacting with the bank.com without her knowledge. Now, how do you do that? Alice is going to know what she's clicking. Not really. What you do is, once you have identified the application that you want to exploit, in this case bank.com, you load that application into an iframe. And then you go about and create a trick page, such as freeipad.com, right? And then you lay over that iframe over that trick page and make that iframe invisible. So whenever somebody is looking at that freeipad.com, they are actually looking at the contents that are hosted on freeipad.com and nothing on that iframe. Little hard to visualize. So I did try to create a demo. Of course, I couldn't find a bank that was vulnerable to clickjacking still. So we have to make do with Tumblr. We have all heard about Tumblr, right? That it allows you to create these blogs that you can share with a group of people, your friends, and post proprietary contents or the private contents on that blog. And you can password protect that blog so that only people that you want to share those contents with have access to that blog. And of course, you can create multiple blogs. So I'm going to, as a attacker, I want to exploit this application and make you disable that password protection without your knowledge that you are actually doing that. So we identify our target application. We identify our goal, that we want to get this password protection disabled. So I want you to click on this checkbox and then click on save. And you would do that if I do clickjacking. So the next step is to create the trick page, which is what you think you are interacting with. And I have to make it such that it has same actions that the Tumblr.com had on the password protection. It has a checkbox, and it has a submit link, right? So I created my trick page. Now I'm going to load iframe inside the, or target inside the iframe, sorry. Did that, and lay over that iframe right where the trick page action contents are. Right here. And now make this iframe disappear. It's gone. The next thing you know, when you, of course, this site contains restricted content, you really want to see this content, so you're going to say, okay, I'm going to click on this, I'm going to click on proceed, and that will show me contents to get the free iPad. To do that, but what you don't realize is what you are actually doing is clicking on this password protection checkbox and clicking on save.
Wait.
Everybody with me?
But when you click on the invisible frame, how does the checkbox below, which is the one the user sees, actually receive the check?
Yeah, it doesn't receive it, but most of the users anyway try to like, okay, why is it's not doing, let me go on the proceed, does anything happen, and it goes forward.
Okay.
So, clickjacking protections. We have to protect against those. Again, we are back to, as a security profession, we are back to Blackboard, that how do we protect against clickjacking? Solution? Don't allow your pages to be loaded in iframe. If you really have pages that have sensitive actions on them, like changing the passwords or disabling passwords, disabling protection mechanism, settings pages, just don't load them in the iframe. And how exactly you do that? There are two mechanisms you can do that with. The first one is called JavaScript frame busting. What it is, it's a script block that checks, is the window where I'm getting loaded, this URL is getting loaded, is it the same as the main browser Windows top URL location? If it is not, then replace that with this and my URL and load it again. So your page, the URL, bursts out of the iframe and into the main window. So seems like it's a little harder to visualize. Let me show you a quick example how that exactly happens. So, what this script is trying to do is trying to load Tumblr in an iframe. And if things are working, just to be sure. Okay. So you see, the main window got replaced with Tumblr. And let me show you the code that just did that. This was the code. You were trying to load tumblr.com in this iframe. But since tumblr.com, if you go look at the view source, here is the frame busting logic that they had. So this logic did not allow iframe to be loaded, this Tumblr to be loaded in an iframe. So let's go back to our presentation. What's the second solution that we are talking about? We are talking about two solutions, right? The second solution is Xframe options response header. What Xframe options response header is, when all the browsers understand this response header, and whenever they see this response header, they do not allow the content of that source to be loaded in an iframe. They reject the request. So between these two solutions, we had clickjacking covered, right? All the applications are secure. You might be choosing JavaScript over Xframe options. I don't know why would you choose one over other, but either one would work and make your application secure from clickjacking. Only until HTML5 introduces iframe sandbox attribute. What this attribute is, it takes one of the four values: allow forms, allow same origin, allow scripts, allow top navigation. And if you do not choose one of this value, the page that you are trying to load in iframe would not have ability to perform any of these actions. So correlate that with the JavaScript frame busting solution. If your page that you are trying to load in iframe is not allowed to execute JavaScript, how is the JavaScript frame busting logic is going to execute? So let's see that with the help of this example. It's ranking. Yay. So no more busting out. It's the same tumblr.com. I couldn't change their code. So what I did change is put a sandbox. Now since I'm not whitelisting that it should allow scripts, it's not able to bust out scripts. Let's see if we can. Obviously, I'm not doing something right, but believe me, this just worked.
I think you signed out when you cleared your history.
Yeah. can just disable that, not have that, and then it will come out. Right? Anyways, but that would work. So now, when EVBOB is trying to trying to perform this clickjacking operation with bank.com, it can just have bank.com with sandbox allow forms, but not allow scripts. So bank.com cannot execute its JavaScript navigation solution. So let's just see. We had a threat report coming out this last month at the security threat report, and some of the guys did a survey across the board. How many people are actually using the clickjacking protection? And out of those, how many are using JavaScript solution versus X-frame options solution? And a whopping 62% people are actually relying on JavaScript-based solution and not X-frame options. So those applications that are secure, that are thinking, or that are under the false impression of that they have done everything to secure against clickjacking, are vulnerable once again. And they have to go back and change their applications to completely rely on X-frame options.
I have a question.
Yes.
If you use JavaScript to render your form, then if they turned off JavaScript, then your form wouldn't be there for them to click on, right?
Right, right.
So would that be a valid prevention method?
Yeah, yeah. But it's not something that you are doing, right? Or, I mean, you are still talking about the using JavaScript to secure the pages?
No, say like your form got rendered from JavaScript.
Okay.
So if they turned JavaScript off so you couldn't bust out of the iframe, then your form wouldn't get rendered either.
Right, right. Yeah, yeah, exactly. So, to be most conservative, you should be using X-frame options. There is actually no reason for not using X-frame options if you want to secure your pages from getting loaded in iframe or any other frame apart from the main browser window. So now thinking that or wishing that all the applications now are using X-frame options, there are no more clickjacking, how do you go about doing the CSRF now onwards? So attacker goes back to the Blackboard, and what if I could I could request the bank form, extract the CSRF token, and replicate it, resubmit it, my request, right? So freeipad.com has to initiate some kind of request to the bank.com and get that CSRF token, right? EVBOB is busy crafting this page. Okay, create a request to bank, extract the CSRF token, create another request, send that token with that request, and I will have my money transferred. But we all know that, right? That would never work. Browser will never make a request from an AJAX request from freeipad.com to bank.com because there is something called same origin policy that gets associated with everything that AJAX does. And there are a lot of applications that rely on that one piece of protection, same origin policy. A lot of things that are hanging on that. And just to give you an example, what kind of applications get built around that assumptions, AJAX is all about performance, right? So there are a lot of applications out there that just build one central page. And depending on the user action that gets taken, they contact the server, get that piece of information or that response, that data, and render that in a designated area on that same page. So you don't have to render the same page again and again. So one such application is, suppose, hypothetically, request router.html, and it has a parameter login.php. That login.php is the user action that user said, okay, I want to click on login. I want to log into the application. Clicks that. That application has a request or the script on that page which extract the value of the parameter go to, and whatever that action is, that becomes the destination for XML HTTP request. So you initiate the request, you give that action, contact the server, and And whenever the response is ready to be viewed or consumed, you incorporate that in the designated area of your web page. So everything of this happens in the JavaScript. Another piece of information to know, that browsers do implicitly interpret relative to absolute URL because there is the same origin. Whoever is initiating this XML HTTP request is where this request action is going. So if you gave XML HTTP request .open login.php, it's same as same domain / login.php. So we are still trusting the browser. That browser is going to make that request, and browser sure ahead makes that request. Response comes back, no matter what the response contains. It can contain JavaScript, it can contain any data that gets rendered or incorporated in the page, in that designated area of inner HTML or whatever you had. Browser renders that, evil Bob comes in and says, hey, it goes to any page that's there on that URL parameter, go to login.php. How about if I can make it go to evilbob.com? What browser gets, since it's a full URL, absolute URL, gets to the XML HTTP request. Browser is trying to make that request, then it notices, it's not the same domain as the same domain. No more. It's not going to go ahead and going to get rejected. And our evilbob disappears. And we are secure, applications are secure, the world is going just fine. Until HTML5 introduces XML HTTP request too. So let's look at how this new XML HTTP request looks like. Everybody notices the difference? Anybody?
It's a newly unique instance?
That's about it. But there is no difference in how you instantiate that instance, or there is no new handler. So your old API is also your new API. So your applications runs fine. They are all now XML HTTP request 2 instead of XML HTTP request 1. And that's where the issue is. You have similar kind of functionality where you get the send the request, get the response, incorporate that in the response, and you make the request. But this is where the heart really starts beating. That you can now make cross-domain requests. If browser saw this, it will actually go ahead and make that request. How evilbob uses this information? It's like, all browsers are HTML5 now. I'm gonna give it evilbob.com. The response will come back, and browser will render it. So all the applications that were relying on the same origin policy, they had Ajax base, they are now all vulnerable again. So that brings us to our developer tip number 2 today. That always use absolute URLs, no relative business, and sanitize your inputs. That's actually true with every security aspect. Whenever you are using inputs, sanitize before use. And do not trust browser same origin policy, because there is none now, or sort of none now. The reason why I say sort of none now, because there is still one more piece of information that's just like hanging by the thread, is evilbob notices that, hey, I can make the request. My browser is now sending this request. Why I don't see any response? You don't see response because what browser, even though it poked a hole for same origin, that it is now sending the request, when the response comes back, it's checking whether the server has this cross-domain policy, whether the server wants its contents to be viewed by cross-domain or not. So you could do that little bit with the Flash, with Flash cross-domain policies, but HTML5 has made this really a piece of cake. So what HTML5 has done, it introduces a cross-origin resource sharing. What cross-region resource sharing is that it allows browsers to make this request cross-domain, and then server defines its policy that, okay, I allow these resources to be accessed by other domains. And this policy gets communicated via policy header, some request and response headers. Just for an example, like domain A is trying to make a request to domain B. When it makes a request to domain B with for a resource, the browser attaches this new header, origin header it's called, and it's the same value as the domain A's name. So it's origin www.domaina.com. Domain B, when the server receives request, it has an opportunity to check that origin header. And I say it's an opportunity for him to check, for it to check an header because it's not compulsory. It can completely choose to ignore that header and give a response back to browser with this another new header called access control allow origin. And that header needs to have a value. It's a response header, and it needs to have a value in its value, domain A somewhere. You can have one domain or you can have a list of domain, but you can also have star for everyone to come and just access this contents. And that's what the new vulnerability that HTML5 introduces. So now let's revisit our CSRF. When we just had XML request level 1, it was restricted by same origin policy. Free API would not have been able to make the request to bank.com, and our anti-CSRF tokens were secure. Come to the world of course and XHR2. Now, freeAPI.com can make a request. In other things, it can define that the response type is going to be document, and when the response is ready for me to consume, let's extract that CSRF token value, create another post request, and send it. When it's creating the post request, you can say, hey, when you send this post request to bank, send it with credential. So what browser does is, whatever credential tokens and cookies it has, it attaches all of that with this XHR request and sends it to the bank.com. So now you have that anti-CSRF token and you have credential cookies and everything. Whole shebang. There is nothing that bank can do to actually differentiate between this request and the request, whether it's been originated by Alice herself or not. So world is insecure once again. Yeah, you may say, like, which bank is going to share all of its resources via wildcard or even have codes on it? Yeah, it would not. And so should you know that you also be careful when you're using codes that figure out if the contents need to be absolutely shared. They are shared. Can you restrict whom you are sharing it with? Or if you are going to share it with everybody on the world, host it on a separate location, different physically segmented, or whatever mechanisms you can associate with that. Take all those precautions. And just to give you an example of how many people actually use codes incorrectly, there was a survey done for Alexa top million sites, and among other headers, they also checked for the values of access control allow origin header. These many sites, and it amounts to almost 80%. 80% of the site had totally wide open access policy for this course cross-origin resource sharing. So putting a star or wildcard is much easier than actually figuring out whom this resource should be shared with, but it's totally worth it. So now I'm going to put this CSRF to rest a little bit. We, I think, beat up on it enough. And going to talk about a little bit about this new area that's changing dramatically, drastically with HTML5, and that's storage. Storage, as we see today, is just cookies, right? HTML5 is way better. Much, much better. Yeah, when I was putting together the slides, I realized that this cookie monster in like next 3 slides, and like everybody's going to start wondering whether we are watching Sesame Street or watching HTML5 presentation. But I think it was for the future course. So yeah, cookies are used to store sensitive information, right? Your identifying tokens and session identifiers and whatnot. And yep, they are precious. So we have done everything that we can to protect those cookies from evil Bob. You have HTTP only flag for those so that they cannot be accessed via JavaScript. So if you have ever seen the presentation just on cross-site scripting, the first thing that they talk about is the cookie theft. Make a request, cross-domain, like load an image and attach document.cookie with it. So if your cookie had HTTP only flag with it, it will not be accessed and secure on user computer. They are secured by same origin policy, they have secure flag, and of course we talk about that you should use encryption for anything sensitive that you store in those cookies. So people have pretty much digested these recommendations, and we see that cookies are reaching there. Until we introduce HTML5 introduces local storage session storage. Local storage session storage is, as you can see with this API, much easier to use and consume. So what you have is key value pairs. You can store just about anything and everything in there. And that's exactly what our helpers are doing. They are storing just about anything and everything like usernames and password on that local storage. Without knowing that, or without realizing that, local storage is not an encrypted source. It's just a plain SQL database on local systems. So anybody who has access to local systems, who has access to their database, and can read anything that gets stored in that database. Not only that, it's not protected by HTTP only flag anymore. So JavaScript has access to everything that gets stored in the local storage and session storage. So session storage was used, it said that, okay, you can store anything that's session related to that storage. And that gets confused with session IDs as well. You are supposed to protect your session ID so that nobody else can do the session theft.
I have a question for you.
Sure.
So it's literally a SQLite database that's installed by what? By the Chrome? By
Built into the browser.
I mean, the browser actually does the
It's
install?
built in, yes,
Yeah.
it's baked in, it's embedded. You just flat files.
Wow, okay.
Yeah.
When they were developing the spec, they actually made a SQL query. Some of the browsers tried to make a SQL queryable implementation, and does somebody have that? I think somebody actually still implements it, but it's not part of the spec. But it's kind of fun to play with.
And it's up to the browser what do they really want to use for that storage. Another thing that it introduces, this local storage introduces, is a new kind of persistent process scripting. The persistent process scripting, that if you know, is something that gets stored in the database, and every time somebody tries to render the page using that data from the database, it gets extracted and gets rendered on the front side, right? So we secure it. Now every time server looks at something that looks like it is including JavaScript in it, it can sanitize it, make data kosher, and then store it. What happens here with HTML5 is you have persistent client-side process scripting. So it's like what happens in Vegas remains in Vegas, what happens on client-side computer remains on client-side computer. Server never has an opportunity to actually view that data and sanitize it. So it's a long time before server or anybody from whoever owns the website hears, unless like it's a really big hack and gets published in the papers and media all over that so many million users got exploited. The exploit remains on the client side, and it's very hard to sanitize and remove this data, this malicious data from the client side computers now, because you don't know who accessed your site. So that brings us to development number 4 today. Do not use local storage, session storage for storing sensitive data. Encrypt before storing if it is sensitive, and do not use confuse encoding for encryption. You always make sure that your keys, encryption keys and algorithms, those are secure as well. If somebody has access to the logic to decode the encrypted data, they are going to go ahead and use that. And of course, don't trust client-side storage. Sanitize cookies. So another thing that HTML5 did, this local storage, or another good thing that HTML5 that did is the limited local storage data to 5 MB. Now think about that. If you could store just about however much data you wanted to store in that local storage, you could fill up users' disk and cause denial of service attack, right? So they restricted that to 5 MB, but that was not acceptable by a lot of people. If you go on the forums, then you will see the posts like this: we as developers need unlimited storage in local storage. Okay, so HTML5 is like the Santa Claus in Christmas, right? Okay, I'm going to grant you that wish.
Just a note to your domain storage with the 5 megabytes. There was a Hacker News a couple of weeks ago where somebody wrote a script to infinitely go to a wildcard subdomain.
Right.
And so the limitation is per subdomain. And
Right.
So you can fill up a person's browser and crash Chrome pretty easily.
Yep. We saw that. So yeah, that limit is actually 5 MB limit is per domain. So you can have as many domains stored data in that, and that way you can make a script run out of space. Yep, that's a good point. And that makes me happy to actually see that you are reading security news. Are you from OWASP? Are you from OWASP group?
No.
Oh, that makes me even more happy. Actually reading security. So what this file system API is? The file system API allows you to create the sandbox area on the client side, which is like just like file system. Like you can create files in that, you can delete, copy, etc. It's just a sandbox environment on the client side computer. And it can have, there are two types of those file system APIs. Like you can either request temporary storage, the storage that you do not care about or do not rely upon being there when you need it. So you can have temporary storage and browser can delete it anytime it's running out of the space. And then there is persistent file system. Temporary file system can have like up to 50% of available disk available space. However, persistent can have unlimited data. Their catch was, before we see the catch, I just want to show you like what are the things you can do in this file system. You can actually request the file system, store data on it, read data, and delete data. Do everything. So the catch was that, okay, if you are trying to request persistent storage, user is always going to have to approve that first. And it's going to say, so nobody can request unlimited storage because user will not allow that. Sure enough, we would have liked that. If it was telling us how much data, how much quota this application is requesting. Localhost wants to permanently, or localhost, whatever domain, wants to permanently store large data on your local machine. Our users have no opportunity to actually see how large that data is going to be. So I'm going to say, yeah, go ahead.
They're just going to click that anyway.
Exactly.
I'm not going to care.
Sure enough, I was able to do that and fill up all of my disk before I was about to shut down. Now another thing, when I was reading, okay, who is going to use this? How are you going to use this file storage, right? So they said, I'm pretty sure you guys are all tired now, so I did circle the piece of information that you really need to read. That you can use the file system API to store when you're doing suppose like file upload functionality. You can copy that big file into this local file system storage that you just created for your website using HTML5 technology. Copy that big file on that local storage, and then user can go about do other business, and you can piece by piece just upload that and not block user while you are uploading this big file, right? Sounds good to me. Now think about all those sensitive data disclosure. So those of you who do not know this WikiLeaks thing, that's fine. The way to correlate this would be, suppose you have this military application. You are uploading, that application is uploading sensitive military plans, your everything onto a central server. The application developer copies that data into the local file system and then never clears it. Somebody have access to the application, military application, and there is one process scripting in that application. Now, anybody who knows about that process scripting can read this data and upload it anywhere else using XHR2, right? So now all of these files get siphoned out of the local storage into the whatever application server they have. They did not know on the local file system where this location is, but they know where the web application, when they say create this file storage and give me access to that, where that is going to read data from. So it's very easy to exploit and gets data out quick. So that brings us to developer tip number 5. Do not leave sensitive data on local file storage. Don't rely on data stored in temporary storage for correct application functions, because that can be deleted without your application's knowledge, right? And don't rely on persistent data storage either, because file system API has delete function, right? And if you have cross-site scripting anywhere on your website, anybody can exploit and delete all of that data from your storage. No, you're not all doomed. You just have to be a little bit more careful, and this is just a summary of all the developer tips that we have seen across this presentation. I'll put it all in one slide. So with that, I'll welcome any questions if you guys have.
Can you bring the other slide back up?
Yes.
This one.
Could you send this out, this presentation?
Sure. We'll figure out to upload it on the site and sure.
So to go back to the iframe talk a little bit,
Sure.
what if I'm working with like an old bank and they have this even older Pro Systems banking software that runs in an iframe? Is there a way to allow that iframe easily, I guess, for that one person I'm expecting to host, or like, you know, my ad aggregator from 2001?
If you are going to poke holes in your security, then it's really hard to secure those applications. So it's the recommendation as security professional would be to just go and implement the security and correct it in all the places and figure out the right way to share information than poking holes in the application.
Okay.
So with persistent storage, you were saying that, at least you're implying that there's no sandboxing. I mean, once you have access to the persistent storage, you can see anything that's in the persistent storage?
No, no, it is actually restricted by domain. So when you're using the application itself, then yeah, you don't have access to other domains data.
Okay.
So, I mean, parent domain will have access to subdomains, and but subdomains won't have access to parent domain, as well as other subdomains, sister domains.
For other domains, you
Yeah.
would be able to directly access that
Yeah.
without doing some sort of scripting attack?
No,
Okay.
that's not possible.
I have an overall question about your examples that you're using in the beginning. You had the web client is talking to the server, and your examples were HTTP, they weren't HTTPS. So if you introduce the SSL encryption, then in order for the hacker to hijack your web surfing to access the bank, wouldn't they also need the key that you're using to encrypt the page info as well?
So that's the beauty of the web application attached, right? That everything is happening in the browser. So everything that browser has access to will be accessible by the attacker's script that he injected in that web application. So there's not man in the middle. It's all happening on the endpoints. Man in the browser. Thanks.
Unless there is a adding JavaScript to that, and that's one way
Yeah,
So
yeah,
I-
yeah. Absolutely.
Any other questions? No? Cool, thank you. Oh, wait, oh, no. You're there, we are.
What Cunningham has been working on a project called Smallest Federated.
What's the question?
Yeah, I'll say what Cunningham has been working on a project called Smallest Federated.
Okay.
And in it, the design is meant to rely heavily on cross-site scripting. So I remember you mentioned that there was a point where most sites these days just say let everything free. Is it possible to be selective in that access about maybe certain trusted domains to?
Yeah, absolutely. So that's what you, like if you check the region header, and then you can have either like the database of all the headers that you, all the domains that you want to allow, check it against that, and if it is not, then just say it's not allowed.
Can you elaborate a little bit on that best practice for whitelisting authorized domains?
Yeah, so I would definitely, I mean, you should be always, let me go back to that slide. So this is really important that if you want to allow domains to have access to some resources, whitelisting would be the option to do that. And if you can't list all the access control allow origin headers there, what you can do is you can check the domain that's coming in the origin header and then check it against your whitelisted domain list, which you can have it in the database or somewhere. And if it is not there, then you can send the response back without this header, and browser will not allow anybody to access that. However, it is still makes your application do that processing. So I don't think I'll touch upon that, just not allowing and posting it on a separate domain keeps your main application from getting hit performance-wise. Does that answer your question?
It does, yes.
Cool. All right, so yes, now, thank you. And for our second talk,
Yeah.
we have a really quick talk on Backbone Detour. So pay attention to this if you're thinking about maybe something that you've done that you can share with everybody, because this is the perfect example of that. So it's only going to be like a 10, 15-minute talk, and we'd love for everybody here to give at least one of those at every meeting, and then we'd be here till like 4 in the morning. But anywho, you good to go? Okay.
Okay, so my name is JD Isaacs and I work for MCN. And Backbone at Detour is something I made for MCN. And I thought it was pretty cool, so I went ahead and open sourced it. And I'm going to talk about that today. Before I get into that though, does anyone here use Sublime Text for their text editor? So a couple months ago I released a plugin for that called Git Gutter. And it's really popular. In fact, it's been ported to Vim Emacs already. So check it out, it's really cool. Is anyone actually using it? What's it called?
It's badass.
Git Gutter?
Yep, it's awesome. Git Cutter?
Git Gutter. It puts your Git diff in the gutter as you type. Alright, so also this is made for MCN, and I brought some MCN shirts, so if anyone wants one of those, have them over here. And so Backbone at Detour, it said alternate way to route your Backbone.js. Alright, so normally backbone.router expects routes to do hierarchies, like path to something, or users/to/posts. But that works great when you're using single page apps, but if you're trying to track application state, then it can become a real nightmare. So let's pretend you're trying to track state of 3 properties, let's say page, sort, and filters. So use a backbone.router the normal way, you would have to define your route like this. And that's because it treats all routes like URLs, so it'll have to be unique. So you'd have to create your route for every possible combination. So you'd have to have your default routes, your one if you're specifying the page, one if you're specifying filters, one for sorts, one for filters with page, filters with sort, and yada yada. That's 8 routes for 3 parameters you want to track. For 4, you'd have to define 15 routes. And that gets pretty big. So backbone.detour takes that pain away. So in backbone.detour, you don't define routes. Instead, you define route options. And that's basically just saying, I'm expecting these parameters. And you do that like this. Oh, by the way, I wrote these code snippets in CoffeeScript. So if anyone doesn't understand what they're doing, just let me know and I'll explain them. So to get to the point, you don't define routes, you define route options. So the previous routes would be simplified to just this. You're saying I'm expecting page, filters, and sort. And then when a route is triggered, then it calls handle route with an object. And that object has keys that represent the parameters that you're expecting. So the normal method of updating the route with Backbone.js is to call it navigate. And you pass in a new path. And that makes sense when your routes are all like URLs. You expect them to change completely. But if you're trying to track state, and you have different variables in the URL that you're trying to track, calling navigate's going to clear everything out. And you're going to end up with code that looks like this to try to keep track of the parameters to recall them into navigate when you only want to change one parameter. So with backbone.detour, you don't call it navigate, you call it update route. And you just specify what you want to change. So you want to change page 2, you just say update route page 2. Now if you already had something in the router for sort and filters, it would be staying intact, it would just change page 2. So since you're just specifying what you want to change, what if you do want to clear something? Then you just set whatever you want to false. So if you say sort name, say you're sorting on name, you don't want to stay on page 2. If you're on page 2, you want to go back to page 1, then you would set page to false. So if you set a parameter to false, and it's a parameter you want, or if you don't have that set in the route, you want to be able to set a default value for it. And you can do that by just, when you define the option, you can specify default for it. And then, whenever you call set it to false, and it triggers handle route, the property on the argument will be the default. It's not set in the route. Now, route changes in Backbone.detour are never silent. In Backbone.js, there are 2 approaches to handling routing. And the first approach is something happens, like you click on a button, or you do something in the Backbone view, and the Backbone view makes the change to the UI. And then it tells the router, update the route silently, so that if the page is refreshed, it'll come back here. But you don't want to tell the router to update to trigger, because you already made the change in the UI. You don't want to have to be like a forever loop. The other way is to not make the change in the view immediately and to tell the router to trigger the new route. And upon triggering the new route, the router then does the logic to update the view at that point. I strongly prefer the second method, and that's what the opinion is used for Backbone.detour. This ensures that your logic is all put in the same place for handling routes. That's because there are 2 ways that a user can end up at a certain route in your application. They can load the page without a route in the URL, and then navigate to their route using the views in Backbone and updating the route. Or they can load that page directly with the route already in the URL. When all routes are triggers, then it keeps the same flow for both scenarios. A route change is triggered either via loading that route directly in the URL, or using the user interaction where you click on something and it triggers the new route. And then in response to that trigger from the router, it then tells the views, hey, go ahead and render the view for this route accordingly. If you don't do it that way, if you do it the other way, then it kind of diverges the flow for the application. You load the route with the page, and then in response, the router tells the view, hey, go ahead and do this. And then the other way is, if you click on something, the view then goes ahead and does it, and then tells the router, update silently. And when you do that, you kind of end up with duplicated logic, because you have the view handling the action when it's clicked on, and then updating the route, and then you have the router saying, oh, when it's loaded like this, tell the view to do this. And I've seen that end up with a lot of duplicated logic that's hard to maintain. So it's also harder to test, because when the view tells the router to update silently, it doesn't ensure yourself that when you refresh the page, it's going to actually, the router's going to know how to render that view the same way the view rendered itself. And then you're going to have to like refresh the page to make sure that it happens the same as if you went to there. But using the other method, the backbone that Detour uses, you get that for free. I also put a lot of conveniences, including support for default values, which we already covered, parameter groups, and the way those are is you specify a parameter group. Say you have 3 parameters you're expecting in your route, and you only want a value for one of them. You would set them to a group. Anytime you set a value for one of them, it would clear the others for the same group. Required parameters. So if you set a parameter as required, then if no value is set for that parameter, then no values are passed to the handle route method, and that ensures that if that value is not set, then it does the default that would happen if no parameters are set at all. And in backbone.detour, all route options and parameters that you're setting have to have a value. If you want something not to have a value, like a flag or a token, then there is a specific syntax for setting those. And it also goes in support for arrays, and there's a lot of unique things added for that. So instead of adding a value, you can set it to an array, and then you can append values. So then anytime you say update route, and you set a value for that particular parameter, it'll append it. And then the value of it back to handle route will be an array. And you can also set it to unique, so if you append it with the value that you've already done, it won't give you multiples. And you can set your own comparators for how to define the uniqueness. And there's a bunch of other stuff that goes into arrays that make it really cool. So if you want any more information about backbone.detour, you can go to the GitHub page, or you can ask me questions on Twitter if you try to implement it and you have any questions. And I made this for MCN, and if you want to work on cool stuff like this, we're hiring.
Hey, we are hiring too.
Do you have shirts?
So, questions? Yes?
Well, you didn't show what the query string looks like as you're progressively updating it. What does it look like in the URL?
So it looks like, say you set a page to 3, it would be the hashtag, and then it would be page/3. And if you also set sort to name, it would be page/3/name/ page/3/sort/name. And that's kind of the same way the background router normally works now when you set a route. So you have a key and a value separated by slashes.
Right. So, I don't want to take up too much time, but so have you looked at Backbone query params?
No, I have not.
Okay. Because like what you were saying was setting up static routes. I mean, that would work, but you could also just use a splat or a wildcard with and have all the params as just optional parameters that define the state, and then that would go to one route, and then you would just decode them to figure that out. That's kind of like a totally optional other way than using just slashes and interpreting routes.
Right. If you do that though, I don't really think the URL is as meaningful. It's like just put some query hash up there. I personally liked it better where you could see it's /page/sort.
Yeah, I mean that's true. That's true.
And there's no having to decode this. You basically say this is what I want, and if it's set, you get a value. You won't really have to worry about handling that. Just kind of abstracting for you. So did everyone understand the CoffeeScript examples? I wasn't really sure if people do that. So any other questions?
What's MCN do?
We do pattern-based analysis.
What's that?
Well, Chris might be able to explain. explain that. Do you wanna give
Yeah,
that-
so like the elevator pitch is we have a mathematician who's one of our founders, and he works in graph mathematics. And so we take in large data sets and we find interesting things like clusters, cliques, communities. And then he outputs that, and then we wrap that up into 4 different products that are based on a Rails and Backbone application stack. So we could tell you all different types of things about data sets. We can tell you which things are highly correlated, which things are always seen together, which things are seen only in certain time frames together, and which things are actually never connected but have friends that are connected. So they're what we call communities because they are loosely federated together and not actual clusters. So,
Who are your biggest customers?
what's that?
Who are your biggest customers?
NCR is one of our customers. We have some intelligence agencies that are interested in these products. We have AGCO, SP Richards, and Home Depot.
And do you have questions?
I was going to ask, so what you're saying is that it doesn't matter what order they're placed in?
No, it won't matter. But you don't have to worry about that either because you don't tell it, you don't give it a string. You give it an object. So when you say update route, you just give it an object with keys and values. You know, you would say sort, line sort equals name, or sort semicolon name, page semicolon 1, or whatever you're telling it you're expecting. And it handles doing that. It handles creating the route and then uncreating the route to give you back what it is. And it wouldn't matter if you were to go in there and change the order in the URL yourself, but it's not even a deeply good
Random thought, maybe I'll go on your GitHub and see about Ignite, but what about validation type ideas? Do you think that would be a worthy addition to it? Or
validation?
So since we had our security talk, making sure parameters are legitimate for what you're
I didn't build anything on top of what the router does. Backbone at Vitor extends the backbone.router, and I'm using it behind the scenes to kind of do all this. So kind of figured, whatever backbone.router is doing is probably good enough.
all right. Probably keep that in the model anyway.
What?
Probably keep that in your models anyway.
All right. Thank you.
Thank you.
Yeah, I guess that you would.